satisfies the inequalities y is bigger or equal to 1, y is less than 4 minus x, and y is less than or equal to 2x plus 1. So we are looking for an area on the graph where all of these are true, where y is bigger or equal to 1, where y is less than 4 minus x, and where y is less than or equal to 2x plus 1. We find this region by drawing all of these lines. And we're going to draw the line y equals 1, y equals 4 minus x, and y equals 2x plus 1. So we can draw the line y equals 1 straight away. So y is equal to 1 all the way along this line. And it's a solid line. The difference between bigger than or equal, or just bigger than, or less than or equal, or just less than, the ones that are equal get a solid line. The ones that cannot equal get a dotted line. So the next two lines, how are we going to draw these? We should be able to recognize that they are straight lines. They're in the form y equals mx plus c. And we are going to draw them by finding some coordinates. So we can make a little table, and then we can pick any coordinates. We're going to do 3. You only need 2 points to draw a straight line, but if you do 3 and they all line up, you know you've done it correctly. So let's do this for both of these graphs. So for 4 minus x, y equals 4 minus x. When x is 0, 4 minus x, 4 minus 0 is 4. When x is 1, 4 minus 1 is 3. And when x is 2, 4 minus 2 is 2. So it's going to go through 0, 4, 1, 3, and 2, 2. So our line is going to look like this. But remember, it doesn't equal it, it can't equal it, so it needs to be a dotted line. So we draw this as a dotted line. So the one that is or equal to is solid, and if it can't equal it, it's a dotted line. And for the last one, 2x plus 1, when x is 0, 2 zeros plus 1 is 1, 2 1s plus 1 is 3, and 2 2s plus 1 is 5. So y is less than or equal to 2x plus 1. So we've got the points 0, 1, 1, 3, and 2, 5. It's going to be a solid line. And it's going to look like that. So now we just need to identify which bit we're going to shade. So y is bigger than 1. Y is bigger than 1 above the line. So we want above this line. Y is bigger than 1 when it's 2 or 3 or 4 or 5. Y is less than 4 minus x. So if y is less than, that's going down. So y is less than going down. And y is less than, again, or equal to 2x plus 1. So again, that is going down. Y is bigger going up and less going down. So what region are we shading? So below these two lines and above this line. So this is our region. If you want to check your answer, you can pick a point. So if we pick this point in the middle of the region, which is 1, 2. So x is 1, y is 2. We can check that this works for all of these inequalities. So the first one, 2 is bigger or equal to 1. That's true. So that is true. 2 is bigger or equal to 1. The second one, 2 is less than 4 minus 1. 2 is less than 3. So that's true. For the last one, we've got 2 is less than or equal to 2 1s plus 1. So 2 is less than or equal to 3, and that is correct. So that point satisfies all of the inequalities, so we know we've got the right region. Okay, one for you to try. So you can pause the video and try and give this one a go. So again, we're going to draw the lines on first, and then we're going to find the correct region. So this time we've got y is less than 4. So we're going to draw y is equal to 4, which is this line here. It cannot equal 4, so we want a dotted line. So we need a dotted line which shows that the symbol is less than or greater than, and not less than or equal to, or greater than or equal to. Y is bigger or equal to negative x. So the line y equals negative x might be one you recognize. So y equals x is the line that goes diagonally upwards through 1, 1, 2, 2, 3, 3, 4, 4, and so on. Y equals negative x goes down, so it goes through negative 5, 5, negative 4, 4, negative 3, 3, and so on. So we can draw that without working anything out. It can equal, so we're using a solid line. And there is y equals negative x. And for the last one, we can work it out by getting some coordinates. So we're getting any coordinates you like. Pick 3, 0, 1, and 2, probably the easiest numbers to pick. 3 zeros minus 2 is negative 2. 3 1s minus 2 is 1, and 3 2s minus 2 is 4. So the line's going to go through 0, negative 2, 1, 1, and 2, 4. So let's draw it on the graph. And where do we want? Which sides of the lines do we want? So y is less than 4. So that's below that line. Y is bigger than negative x. So above our second line. And y is bigger than 3x minus 2. So above, again, this line. So our region is usually the one in the middle of all of them. So this is our region, and again we can get a point to check. So if ever you're not sure about any of them, you can use a point to check. So let's use 0, 2. So if we use 0, 2 to check, x is 0, y is 2. So that's in our region. So it should be true. It should make all of these statements true. So 2 is less than 4. That's true. We've got 2 is bigger or equal to 0. 2 is bigger or equal to 0. And the last one, we've got 2 is bigger or equal to 3 zeros, which is 0 minus 2. So 2 is bigger or equal to minus 2. That's correct as well. So we've got the right region. Here is a different example. This time we've got the lines and the region drawn on the graph already, and the question says write down the inequalities that define the shaded region. So we need to work out what the equations of these lines are, and then also work out what the symbols are, whether it's greater than, less than or equal to, and so on. So let's start with working out the equations of these lines. So we've got a vertical line here that is x equals 4. So this line is x equals 4. We've got a horizontal line that's y is equal to -2. And we've got another straight line. The equation of a straight line is in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So for every one it goes across, how much does it go up? That's the gradient. So this line goes across 2 up 1, across 2 up 1, which means for every one it goes across, it goes up half. So the gradient is a half. The y-intercept is -1. It crosses the y-axis at -1, -1. So the equation of this line is y equals half x minus 1. So we've got the equations of the lines. Now let's work out the symbols. So for x equals 4, the region is to the left, and that means less than. So x is less than to the left. X goes up to the right and down to the left. So that's x is less than 4. So x is less than 4. It cannot equal it. It's a dotted line, so it's not got an or equal to symbol. For y equals -2, the region is above the line. So y is bigger than -2, and it can equal -2 because it's a solid line. And for y equals half x minus 1, the region is below the line, so y is less than. So y is less than, and it can equal it, so less than or equal to half x minus 1. Again, we can check our answer using a point. So if we pick a point within our region, 3, 0 is a nice one. So we take 3, 0, and if it works for all of these, that means there's a good chance we've got it right. So x is 3, y is 0. So 3 is less than 4. That's true. 0 is bigger or equal to -2. That's true. And 0 is less than half of x minus 1. So half of 3, 1.5 minus 1 is half. So 0 is less than half. That's true. Okay, one for you to try here. So pause the video and give it a go. So let's write down the equations of these lines. So we've got y equals 4, and we want below the line for our region. So y is less than or equal to, it's a solid line, 4. For our vertical line here, that is x is equal to 2. We want less than that line. We want to the left of that. So x is less than or equal to 2. And the equation of the other line, so it's in the form y equals mx plus c. For every one it goes across, it goes down 2. Across 1, down 2. Across 1, down 2. So m is negative 2, the gradient is negative 2, and the y-intercept is at 3. So it's y equals negative 2x plus 3. And we want y is bigger than that line. It's above the line. So y is bigger or equal, because it's a solid line, to minus 2x plus 3. Okay, 2 questions to finish up. So pause the video and give them a go. Question 1, shade the region that satisfies the inequalities. So we're going to draw these lines. So y is less than half x plus 2. So let's plot a few points. I'm going to pick 0, 2 and 4 this time, because when I half them, I'm going to get a whole number. So half of 0 is 0 plus 2 is 2. Half of 2 is 1 plus 2 is 3. And half of 4 is 2 plus 2 is 4. So it's going to go through 0, 2, 2, 3, and 4, 4. It's got a y-intercept of 2 and a gradient of a half. So for every one it goes across, it goes up half. And we are going to want to draw a dotted line this time, because it cannot equal. It is not an or equal symbol, it's just a less than symbol. For the second one, y is bigger than x minus 2. So we're going to have a y-intercept of negative 2 and a gradient of 1. So for every one it goes across, it goes up 1. So let's draw that on. And again, it's a dotted line, because it cannot be equal. And we've got x is bigger than negative 2. So x equals negative 2 is here. And again, let's change that to a dotted line. Okay, so where is the correct region? So y is less than half x plus 2. So that's underneath the line. Y is less than means go down. Y is bigger than x minus 2. So that means go up. And x is bigger than negative 2. So x is bigger on the right. We go right for x is bigger. So our region is this. And we can check our answer by picking a point. We've got 0, 0 in our region, so we can use that. So 0 is less than half of 0, which is 0 plus 2. So 0 is less than 2. That's correct. 0 is bigger than 0 minus 2. So 0 is bigger than negative 2. That's correct. And 0 is bigger than negative 2 again. That's correct. For question 2, write down the inequalities that define the shaded region. So what are the equations of these lines? So we've got y equals negative 3, and we want bigger. So y is bigger than negative 3. For which line should we do now? So the line with a y-intercept of 3. So C is 3. For every one it goes across, it goes up 2. It's got a gradient of 2. So we've got y equals 2x plus 3. And we want below that line, so y is less than, y is smaller. And it can equal it. And our other line has got a y-intercept of 0, and for every 1 it goes across, it goes down to a gradient of negative 2. So y is negative 2x plus 0. We don't need to write that. And we want below that line. So y again is less, y is on the smaller side, so less than or equal to minus 2x. We can pick a point to check our answer. Let's do negative 1, 0. So 0 is bigger than negative 3. That's correct. 0 is less than or equal to 2 times negative 1 plus 3. So that's 1. So 0 is less than or equal to 1. That's true. And we've got 0 is less than or equal to negative 2 times negative 1, which is 2. So 0 is less than 2. That's correct.